So that will be the end of the official design and the official layout. So again, you're welcome to stick around if you want to watch me finish this PCB. So I'm just going to get started on that. So we're going to start here with our designators. Now I'm going to start with the battery inputs. I never, for the pads and stuff, I never use the built-in designator for that. I always just name it with a text box. So rather than, I figured out a long time ago, rather than trying to fight to try to get the designator to be what I wanted it to be and say what I wanted it to be, I just throw a text box on there. Just throw a text box on there. So I don't want to select polygons. This is your selection filter. It's very helpful whenever you have copper pores. Very, very helpful when you have copper pores. Battery minus. There we go. So this will be, you know, battery plus, battery minus. Look very good. Look very good. So, and then again, throwing these over here. Same thing. This will be pack plus, and then this will be pack minus. So that'll be pack plus, that'll be pack minus, of course. So then I'm going to do this, components, select all components, and then show all designators. However, I'm going to have to turn off the designators for these 4. Right? So, got to turn off the designators for these 4. And then, where is my PCB filter? So, I want to select... No, I don't want to select rule. I want to select PCB objects list. I want to do designators. Text. I think it is designator. That's what I want. So this is the PCB filter. So this lets you select there we go. So this lets you select all the things in a PCB. In this case, it's designators. I get to select everything that is a designator. We get to see all the designators here. The reason for that is I'm going to change all of their heights and I'm going to change all of their widths. So I'm going to go 0.6 and then 0.2. 0.6 and 0.2, and there we go. There's all of our widths and heights changed. Look at that. And then we hit clear filter. Bam, there you go. So now I think I need to go a 0.8. I think 0.6 is a little small. Let's go 0.8. There we go. That's better. And then clear filter. So there we go. Just a little Altium tip there for you. I'm sure that other places have too. So I'm going to select text up here in my selection filter. J1, J3, R4, R1, R3, and then R5, R6. What grid am I on? Oh, I need to be R5, R6, R8, 10, 14, C1, 6, 9, 11, 8, 4, 3, R2, C2, E1, R12, what is it? Yeah, I can do this. R12, R13. When you go to lay out a PCB, all your text should be the same. So, the same direction. So, and sort of the same orientation. So, I usually follow the rule that, so if you look at it here, if it's a bigger component, I'll leave it horizontal. So, I'll leave it C1, C2, I'll leave it horizontal. It's a bigger component. If it's a smaller component, I'll turn it sideways like this because it doesn't fit well. So, like here, I didn't realize that was going to be like that, so I'm going to fix R13. So here's what I'm going to do in this situation, just to show you something that you can do. So you've got R12 and R13, right? And you're going to put them here. What we're going to do is we're going to go to our top overlay layer, and we're going to draw. We're going to draw a line right here. We're going to make it thicker. Hit Tab. Point 2. We're going to draw a line right here and make it thicker, and then we're going to shift spacebar to get, there we go, to get our routing, and we're going to do like this. What that does, it's not necessary in this situation, but I'm doing it just to show you. So what that is see, now this is R12 and R13, R12 and R13. Just something that you can do when you're in a tight PCB layout. Not necessary. See, like right here in this situation, move C10 over here and move R15 right here. See, just like that. So really it wasn't necessary. What I would normally do is just move R12 and R13 right here beside of each other, and then move C11 down here. But just something neat that you can do whenever you're trying to designate your PCB. So R11. You can also do this in the 3D model as well. So, like right here, it's facing sideways. I'm going to turn it sideways. R19, and then D1 I'm going to stick here for right now. I'm going to put Q1 here, and I'm going to put D1 here just because I don't want to put anything next to this polarity mark right here. Then Q2, D2, R22. Where's my designator for that component? Where is your designator, little component? Where's your designator at? Wait, R22. I thought. Oh. So your designator must be wrong deal. Sorry, forgot to change my. So you're going to be R22, R25, Q4, Q3. Where's your designators? Your designators are here. Oh. How do I want to do this? So that's the obvious place for that, and that is the obvious place for that. What about Q? I guess I can put them here, and they'll look fine. They will look fine. They don't look fine. Yeah, I guess it looks okay. So what we'll do is we'll do this one here to match. This one here, and then this one here to match. Yep. One over. Yep, I think that's good right there. And then of course J2 right here. C7 and C5, of course, and then F1. So yeah, that looks I think that looks good. That looks very good. Now, another thing I want to do is I'm going to take and copy these copper pores to the bottom layer and then throw some via stitching around for some heat dissipation. Again, nothing electrical, just for some heat dissipation. So what I'm going to do is that, and then I'm going to do edit, paste paste. I missed it. So I got to do all layers. There we go. So let's go back through it again. Control C. To the bottom layer. Edit. Paste special. Paste. Paste. And then we're going to throw... Let's do... There we go. So what I did there was remove dead copper because it did not have any traces or any net objects connected to it. So it thought it was dead copper. So you gotta do that. So what I did here was I created just a bank of vias that I can work with here. So I'm just gonna throw these around. Again, no electrical purpose whatsoever. Just simply to help with heat. I got that one off, didn't I? Just simply to help with heat. And that should be fine right there, probably. Yeah, that should be fine. Just a little bit to help with heat. Let me throw some more right there. That should be fine just to help with heat. Then we'll do the same thing right here. And then once I'm done with that, I think I'll be done for tonight. Probably. We'll see. So we're going to do Control C. Then we're going to do Edit, Paste Special. Paste. There we go. And then we're going to make sure that there we go, do that. And then we're going to take and I'm going to copy some of these vias. I'm just going to throw some of these vias around. Gonna copy this. Well, first I'm gonna move this down because it looks stupid, and then we're gonna copy. We're gonna paste that. We're gonna paste that. Delete these, and throw some down the side right here. Again, not electrical, just to try to help with some heat dissipation. So, same thing here. C. We'll paste off of this one. It's easier to get to. We'll do Edit, Paste Special, Paste, and then there we go. And then we'll copy some of these vias right here. Not a lot of room to add them in down here. but you want to add as much, you know, as much thermal relief as you can. That ain't going to be very much, but it's fine. And then, of course, we got this plane right here. And then we'll add some in here. Oh, I forgot there we go. Then we'll add some in for this plane right here. So Control C. Then paste special. Paste these two. Paste. Then we're going to hit remove dead copper. Come over here. Copy some vias. Control V. We're just going to paste some. Then we'll paste some up here too. Again, not electrical, just for heat. And then last but not least, this copper pore here. Paste special. Paste. I got that off a little bit. Yeah. Paste special. Paste. There we go. And then there we go. We're going to copy some vias. And I got a trace in there too. I need to get rid of that trace. Oh. So when you move vias, they keep their original properties, so you can't just move them like I just tried to do. Or else it won't couple to your copper pore. Okay, so let me throw some down along here. Again, not for electrical, just for just some thermal. Okay. Okay, I think that's looking quite nice. Look at that. That looks quite nice. Just simple as it can be. It's not very much. I think there's like 30 components on this whole thing, or 30 or maybe 32, somewhere around in there. Your main battery connection, your positive connection, main negative connection. All right, now to these connectors. Let's just go ahead and do these connectors. So let me open up my schematic library here. Let me see. So I've got all of these as straight, and I need right angle. Which one of these are right angle? Let me... One cool thing about this is you can go here. Well, that's LCSC. You can go here, hit this button, and then it'll pull you up. It'll pull you up whoever your vendor is. So usually DigiKey will throw down here whatever the right angle is version of this. Let me look in the data sheet. The data sheet will tell me. Which version is the right angle? That's the through hole. There we go. Is this a header SMT type? Top entry type, side entry type. So S, the S designator is what I'm looking for. So we go back here. This is B. So let me look and make sure. Which ones am I using? I'm using the 4, and the 6. So let's start with the 6. Is this right here? So this is my part number. This is my part number. So I'm going to go to manufacturer's part search. I'm going to go here. I'm going to search this part number, right? Okay, it works. Okay, that's the right number. So I'm going to change this to an S and search again. Haha, look at that. Look at that right there. So what I'm going to do is I'm going to... That's interesting. It's got 2 of the same, 3 of the same. That's interesting. Yeah, I didn't program the thing. I don't know. It looks like the S series is not. Let me check DigiKey here. They're in stock. I don't know why DigiKey is not in the list. Let me try searching. DigiKey is not in the list. I'll just choose Arrow. I'm going to order all my components anyway. So import. So I've imported it now. One neat thing, I'm going to be lazy here. Check this out. There's already a footprint available that I can just base off of and then go with it. So guess what I'm going to do? I'm going to save it. Alright, so I want to do this. And what I'm going to do is I'm going to copy this. And I'm going to open my PCB library. I'm going to stick it in it. And then I'm going to edit it. So I just did that. So one thing I'm going to do is definitely get rid of these. These don't have designators. These are mounting pads. Mounting pads don't need designators. I don't know why they put designators on mounting pads. Okay, so what layer are you? You're mechanical. Okay, so this has got mechanical. So this is the old style. I've stopped doing this. So mechanical 15 is your top courtyard, and then mechanical 29 should be your. Well, there's nothing on it. Your top component center. I think I stuck that in the courtyard. But Altium has a lot of nice custom layers now, and so I use those. So that looks ready to go, except for the assembly layer, top assembly. So let me do that. So here's how I did the top assembly for the others, right? So I'm just going to sort of copy that. Where do I want to copy off of? We'll do the center. We'll do center of pin 3. So what are we looking at right here? Oh no, I didn't want the whole thing. I wanted Shift S gives you Shift S gives you layer isolation, so you can just see the one layer. That's with it grayed out. That's with it fully just by itself. And so let me go here. What of this is usable? I can use a lot of this. Okay. I'm going to do that. I'm going to turn this designator around. I'm going to delete that designator. I don't know where that came from. And then I want to expand this out. Actually, I'm going to drag this up to here. I think. Oh. Okay, is that how it's? Okay. Okay, I see now. Okay. So, I'm going to move these back to where they were. I'm going to bring the body back to it. Oh, that's the wrong thing. and then extend these out. And then there we go. There we go. That's the assembly layer for that. So that is ready to go. And so we just go here and add this as the footprint. Oh, I didn't rename it. Did not rename it. So go here. And then take out all this. There we go. Do that. Grab the schematic symbol because it's just a schematic symbol. So grab the schematic symbol, put it in here. Connector name is the comment, and then J question mark is your designator. And then your footprint is this one. Don't ask me why JST's footprints are blue. Don't ask me. I have no idea. I have no idea. Anywho, so let's finish this up. So let's save that. Then let's do the 4-pin one. I believe this is the last thing I need to do, and then we'll be ready to go. So I believe this is the last thing that I need to do. So we'll do this, except we'll change this to an S again. DigiKey. Import, and then there is no nobody has a footprint. Don't tell me that. I don't want to make a footprint. Let's try that. I don't want to make a footprint of this, but I guess I will make a footprint of this. Well, those of you who are still watching get to watch me make a footprint. Make a custom footprint. Okay, let me get all this fixed first. Let me just go ahead and do that, and then I'll make the footprint. But y'all get to watch me make a footprint. I don't want to make a footprint, but I will make a footprint because I'm going to finish it. This BMS will be orderable by the time I'm done with it today, which I'm not going to show you the process of creating the documentation because that's all stuff company related, and I can't show you that. So, okay. So let me go back. Where's the data sheet at? Data sheet should be here. So I'm going to put that over on my other screen, and we're going to go back over to PCB library. We're going to copy this because it will be, it will be the same pitch and everything. So if I'm right, go to the footprint section here. Yeah, it's all the same. It's all the same pitch and everything. So let me show you a trick to do this. That's pin 1. So we need to get out 5 and 6, but we need this to be the same relative to this. So what we're going to do is we're going to copy this. Copy it to this pin here. Okay. Then we're going to delete this and delete this. We're going to paste it. Make sure that ain't interfering. We're going to paste it to this pin here, and then we can delete this one. There you go. Look at that. So great. It's so great. It's so great. It's so wonderful. So anyway, just a little design tip there for you. So what we're going to do is we're going to do that. We're going to do that. We're going to move our designator over. Then we're going to move this over and this. Nope. Quit. Why don't you move this over? All right. just like that. We're going to move this over to here, and we're going to move our designator back. And then we're going to go to our top courtyard, of course, move it over here. Then we're going to take our oh, does that still have the mechanical 13? I need to delete that out because it's not useful anymore. Then we need to take edit, set reference, center, back to center. Make sure you do that if you're going to do what I'm doing. Then we want to move our center to the center. And then of course we need to adjust our top overlay. There we go. Last thing we need to do is find a 3D model. So need to do that. I need to find a 3D model. So let me go to JST USA's website. And then we're going to put in the, well, I'll show you this. Whoever's still watching, I'll show you this. So we're going to go to JST's website. We're going to put in the number. Where's the search bar? Their website is notoriously hard to navigate. Terribly hard to navigate. I think we're looking for the pH connector. Yeah, we're looking for the pH series. I don't see a 3D model. I need a 3D model. I know there's a 3D model somewhere. Let's go here. Product profile. Okay, there we go. We need the S6B. No, we're not doing the 6, we're doing the 4. I need the S4. pH. Oh, which column was step? Step model. You need a step model when you go to do this. Download step model. Oh no. Well, I guess I'm going to enter a bunch of information. I'll do that off screen. See, I ain't got all my personal information. Oh, it remembers me from the last time. It's just helping me fill in all my stuff. That was a lot of work. Okay. All right, that was a lot of work, but I got it. All right, so let's do this. We're going to go place. Oh, I don't want to show you all of the company junk. So let me transition back to my face while I do this. I'm going to go place 3D body. Okay. Okay, now you can't see the company junk. Okay. Place 3D body, and we're going to hit open, and we're going to just place that. I have no idea what orientation it's in. I placed on mechanical 13. It needs to go to top 3D body. Sure, a lot of work. It is a lot of work to create a footprint. It is. That's why I was like, I don't want to create a footprint. It's a lot of work. It's annoying to have to create a footprint. It really is. I hate creating footprints. If you have a big, that is not the right solid model. Where in the world did that come from? It's not the right solid model. Hold on just a second. That must have been from a design I did today, or the other day. So let me transition back to my face. Tools, 3D body place, place 3D body. Okay, now you can look. I'm decent, or everything's decent. Now you can look. All right, let me go to. I was in the wrong folder. Yay. Okay. There we go. Oh, I accidentally put 2. It's Paste Mechanical 13, and I'm putting it on top 3D body. But it is sure a lot of work to do this. It is sure a lot of work. Okay. So if you notice, the connector's over here. It's up in the air. It's terrible. So what you go is Tools, 3D body placement, align face with board. So this is what face will be in contact with the board. So you select the thing, and then you want, the bottom face to be in the board. And there we go. So let's take it, we're going to rotate it around, and we're going to get it, lined up the best we can. Sometimes the mechanical designers will fuss at you because you haven't got it lined up exactly right and it's not perfect. Well, guess what? Altium's not a perfect tool. It's just how it is. Okay. That looks good to me. So we're going to click Save. Then we're going to go here, add footprint. It takes, if you've got a big BMS design to do, it takes days. It literally takes days to build the libraries because you have to, if you do not have the component libraries already ready to go, it takes you days to build the libraries. If somebody else does not have a component library ready to go, it takes you days to build the libraries. It just does. Something that's not, it's not fun. It's not fun. So normally I would do the whole, replace component thing, but since I'm just doing these connectors, I'm just going to do them straight from the thing. So I'm just going to do this, and then I'm going to just delete this, put this in its place, and then rename it J1. You need to make sure you rename it, and so that way the software knows to place this back in its place. Then I'm going to go to components. I'm going to grab the 4-pin one, which is right here. I'm going to do this. I'm going to just delete this one out, put this one back in its place, and then call it J3. Same thing over here. I'm going to delete this one out and call this one J2, and then the software knows to replace J2 with this one. So that's what I'm going to do. I'm going to take this, I'm going to save it. I'm going to go to Design, Update PCB Documents, automatically create these links, and then don't add the room, execute changes. Close. I need to. Wait a minute. Wait a minute. Wait a minute. It didn't update. It didn't update this one. Yeah, that's right. What do you mean you cannot match pad with new footprints? Are you attached? You are attached. I wonder if they're pinned out the same way. They should be pinned out the same way. I mean, it's not. Oh, great day. So circuit number. Oh, they're backwards. They're backwards from each other. See, for the top facing circuit number 1's over here. For the bottom facing circuit 1's over. For the side entry, the bottom. Okay, circuit number 1's over here. come on. That is dumb. Okay, so that means I need to go back here and I need to flip this back over. Oh. I need to go over here and flip this back over. Now I should be able to. Cannot match new footprints and component. Why can't you match the new footprints and component? Also, did I put a room in here? I think I did. I included a room. Where is it at? Are you the room? Great. I put a room in here. I don't know where it's at. Okay. Okay. So I need to go back to the okay. So 1, 2, 3, 4, 1, 2, 3, 4. Those pins are correct. This pinout is correct, and this pinout is correct. Okay. 1, 2, 3, 4, 1, 2, 3, 4. That's correct. 1, 2, 3, 4, 5, 6. That is correct, I believe. Yep, 1, 2, 3, 4, 5, 6. That's correct. Said Altium has bugs. All softwares have bugs, right? It does have some bugs. It does have some bugs. So don't get me wrong, it does. So I'm just going to delete this out. I'm going to put another one in here. I don't know why it can't rematch the pinout. Cannot match the pad with new footprints. Well, why can't you match the pad with new footprints? Then here's how I want to fix that then. Okay. I know I need to take these and rotate them around so they'll orient right on the PCB. I'm going to not call this J. I'm going to call this J3, J4, so it creates a new component. And then see if I can fix it that way. Okay. Okay. Wonder why it didn't take over that, but that's fine. All right, we're going to do this. We're going to do this. There we go. We're going to rotate this around. Bam, there we go. Oh. What are we looking at here? What's wrong here? Oh, okay, it must be coming over further. So let's just take and we'll just like that. Okay, just like that. Yeah, that's fine. Oh, that's good looking right there. That's looking real good right there. Okay. And then this one obviously needs to be turned back around as well. May need to be backed up a bit. It does need to be backed up a bit. So let's go ahead and quit jumping around on me. Okay. Okay. He's backed up a good bit. Okay. So this is thermistor 2. We'll go ahead and put that back here. Power ground. We'll do this. No. We ain't gonna do that. We're gonna do this. System present. And then pack plus. J2 needs to be fixed. We'll put that here. Okay. I think she is ready to go. Now let's go. Last thing to do is run a design rules check. First thing I'm going to do is minimum clearance is 0.2 for everything. Oh, you know what? Except for the cancel. I didn't change that, didn't I? It is 0.2 for everything except for the short circuit, unrouted net constraint, routing, topology. Here we go. Minimum solder mask. All right. 0.2. 0.2. Silk to silk. 0.2. Quit. Done. Border line clearance, I've already got that 0.3. Component clearance. 0.2. Minimum horizontal clearance. 0.2. Apply. Did you keep all my settings for? Okay. Okay. Now we're going to run a design rules check, and it's going to yell at me that a bunch of things are wrong. Unrouted net constraint. All right, let's check that first. Oh, yeah, because I don't have the through holes on here anymore. I got you. That's right. Okay. Now, what's next? Minimum solder mask clearance. Okay. So when you have a situation like this, minimum solder mask, okay, a minimum solder mask silver constraint within a component like this, you need to create a special rule for the component. So minimum solder mask silver, we're going to put a new rule, and it needs to be above. It needs to be above the rule, regular rule. Footprint, no footprint, and we're going to call out the TSSOP, and we're going to make that a 0.01. That's going to be ignored. Okay, so we're going to run the design rule check again, and we're going to see what we got now. Silk to solder mask clearance, pad C10. Okay. So we're going to create a special rule. Silk to solder mask clearance is pad. Okay, here's how I normally do this. So I will do something like this. I will do footprint, capacitor 0805. Is this 0603s? No, it's 0603s. I'll go capacitor 0603, and then I'll do custom query. Copy that. Just take that back to all. Take this back. New rule. Paste that. CAP 0603. That's what I'm going to call this rule. Apply. Okay. Save that. And now we're going to run it again. Going to run it again. We've still got 97 to go. Oh, I forgot to change the rule. No, this is for pad R11. Same thing. So what we're going to do is we're going to go design rules. And we're going to do... Oh, my bad. I put that on. I didn't put that on the capacitor footprint. Oh, and I should have changed that to 0.1. I didn't do that right. Let me do that again. Tools, design rule check, run design rule check. Okay, we only have 8 left. Let's see. Silk to solder mask clearance. Okay, so those are real violations. We need to back those away. There's another violation. What else have we got? Oh, we got another violation over here. And then what else we got? Already got that one. Already got that one. And R10. R1. Oh. Okay, so we're going to go Tools, Design Roll Check, run it again. What if my board will have more current than specific for this board? How do you know what clearance to use based on current? Clearance of what? So that would be my question. It's clearance of what? So generally, as long as you ain't got any sensitive signals, you can, having things next to your high current stuff is not major. Oh, look at that. We got 0 violations. Awesome. Okay. I won't show the actual documentation process because some of that documentation stuff is proprietary to PTI, but look at that. We have a board. It's a beautiful board. Look how beautiful it is. I am quite happy with it. It's kind of empty over in here. I think I need to throw you know what? I'm going to throw the board name. This is BMS Design Series Revision 01. So we're going to throw that right there, and we'll text height, we'll make that 2. Stroke width, we'll make that 0.5. And we're going to throw that like right here. Look at that. Look at that. It's going to be beautiful. It's going to be beautiful. All right. Well, I'm quite happy with that. I think this is going to make a good little BMS for this drill pack. We'll see. We'll see. Trace to trace. Okay, so again, it depends on your application. So, you're going to do, you got some sensitive analog circuitry. You need a pretty good trace width away from that. And then maybe some kind of isolation in between. But depends on how much high current you're running, and if you're pulling more than 30 amps, you don't want anything attached or that could couple to that plane that's going to mess up your signal. So that's definitely a big thing. Okay, well, thank you so much for watching. I've enjoyed it. Everyone. I'm finished with this board now. I think it is ready to be ordered. Is good. I think it looks good. So it is ready to be ordered. So thank you everyone so much for watching, but I'm going to, wrong button. I'm going to end this stream here. So I thought it was fun. I thought it was awesome. So thank you everyone so much for watching. Those of you who stayed, the 2 people that have stayed, thank you so much. And this video will be up as soon as it finishes processing. I'll go back through and edit all the other parts out and all that stuff. So again, thank you so much for watching, and I'm looking forward to the video where I have this thing ordered, and we're going to, of course, populate it and then install it. So I thank you everyone so much for watching, and yeah, this is it. I'm going to go home, eat me something, and go to bed.